Hello friends, I am NKJ from skillontech.com. After a long back, I am again coming to share some more videos that will be helpful to enhance your knowledge. So all mechanical engineers and piping engineers will get knowledge how to complete a piping project. So this will be very much helpful in their job profession, that how a piping project shall be completed. If you like this video, kindly share it with your friends and colleagues. Process and power plant piping. Piping is a lifeline of process and chemical plants. Without pipeline, no process and power plant can be set up or operated. Piping system conveys fluid between different process locations. Piping system includes pipe, fittings such as elbows, reducers, branch connections, elbow let, socket let, reinforcement pad, etc. Flange, gaskets, bolting, oblique studs, process walls, safety walls, pipe supports, spring hangers, pumps, tanks, etc. Important codes related to piping. As a mechanical engineer or piping engineer, we must know the piping codes which are very much essential to complete a piping project. So, what are that codes? ASME codes, American Society of Mechanical Engineers. ASME B31.1, that is a code for power piping. ASME B31.3, that is a code for process piping. IBR Indian Boiler Regulations for projects in India. What are the common materials which are used in piping? Commonly used ASTM carbon steel pipes, ASTM A53 grade A or B utility services pipes, ASTM A106 grade A, B, C high pressure pipes, commonly used ASTM stainless steel pipes, ASTM 312 TP304, TP304L, ASTM A312 TP316/316L. Other than this, in carbon steel, alloy steel pipes are also used for high pressure and temperature services. Some important codes and standards. ASME B36.10 welded and seamless wrought steel pipes, ASME B36.19 stainless steel pipes, ASME B16.1 cast iron pipe flanges and flange fittings, ASME B16.5 pipe flanges and flange fittings, ASME B16.9 factory made wrought steel butt welded fittings, ASME B16.10 face to face and end-to-end dimensions of walls, ASME B16.11 forged steel fittings, socket weld and threaded, ASME B16.34 wall flanged threaded and welding ends, ASME B16.47 large diameter steel flanges. Scope of piping. Inputs. First of all, we should plot a plan. Process and instrumentation diagram. P&ID. It shows the interconnections of process equipment and the instrumentation used to control the process. It is a pictorial representation of key piping and instruments details used for basic startup and operational informations, control and shutdown schemes. Process data sheets, equipment list, general arrangement drawing, wall material specification, piping material specification. These are the inputs which are required for a piping project. So you can see a P&ID diagram is shown. Outputs, bill of material, piping isometrics. That will be required us to execute the piping project. Selection of piping material. Selection of piping material is very important and a key point to enhance healthiness of your piping project. To select appropriate pipe material based on flowing fluid properties. Find out type of fluid flowing, find out fluid temperature and pressure, check pipe life expectancy, select suitable material as per past experience, cost, design, code, etc. This is also very important because in past with what material, what is our experience? If the material has not survived and not given a good service to us, then we can go a upgraded material. So that will enhance life of your pipeline. If material selected is not available, find next closest material and check suitability. Pipe sizing and thickness calculation. This is very important. Once we have come up for a piping project, then we have to select is pipe size and a thickness calculation shall be made with regard to our pressure and temperatures and flow. To select appropriate pipe diameter based on velocity and pressure drop, first find out fluid flow volume per second. Check allowable velocity per second. Calculate flow area required and pipe size. Calculate pressure drop for that size. Check if pressure drop is within allowable limits. If not, increase pipe size and again check pressure drop. Finalize pipe size. To select appropriate pipe thickness based on fluid properties, select material and diameter as above. Find out fluid temperature and pressure. Decide on corrosion allowance. Calculate pipe thickness as per code. Select closest pipe available, satisfying all above requirements. So how to do piping calculation? So we have to calculate the line size or pipe size. Pipeline is sized based on continuity equation Q equal to area into velocity, where Q is equal to flow meter cube per second, area inside cross section area of pipe meter square, V velocity meter per second. So with this formula we can calculate the pipe size. Pressure drop calculations. Darcy formula for steam, oil and air services. William Hazen formula for water services. Weymouth formula for gas services. So Darcy formula is, which is generally used, HF equal to FLV square upon 2GD, where HF equal to head losses in meter, F is a friction factor, L is a length of pipe in meter, V is a velocity meter per second, G acceleration due to gravity meter per second square, D inside diameter of pipe in meters. So with this formula we can calculate the pressure drop in our pipeline. Pipe wall thickness. This is very important. We have to calculate pipe wall thickness so we can decide a schedule of the pipe based on pipe wall thickness. So nearest schedule shall be used, means as per pipe wall thickness, the higher schedule which is available in the market shall be taken for use. So how will calculate pipe thickness? Pipe thickness calculation as per ASME B31.1 is Tm equal to PD0 oblique 2 bracket SE plus PY bracket close plus A for outside diameter based pipe, where Tm is equal to minimum required wall thickness in mm, P internal design pressure, gauge pressure kilopascal, D0 outside diameter of the pipe in mm from ASME B 36.10 or 36.19, S maximum allowable stress kilopascal, EF weld joint efficiency factor, Y is equal to coefficient. So with this we can calculate the wall thickness of the pipe. In any piping project, flanges are very important. So selection of flanges shall be a important task. So how we'll do it? Select suitable material for flanges as per pipe material and designed as per pressure and temperature. Below 2-inch size, use socket weld flanges for process and high pressure steam pipelines. About 2-inch size and pressure about 10 kg per centimeter square gauge, use neck weld flanges for process and high pressure steam pipes. System pressure less than 10 kg per centimeter square gauge, other silicone flanges can be used for utility services. Piping drawings. Piping drawings are very important for completion of a piping project. So following drawings shall be prepared by consultant of engineer for execution of project. General arrangement drawings, GA drawings, P&ID process and instrumentation drawings, piping isometric drawings. So piping, the P&ID drawing shall be helpful to know us the process and arrangement of equipment and machines in plant and their connections with pipeline. The equipment erection is possible with the help of GA drawing only. So you can know where that particular equipment is to be installed in the particular location. So we must have a GA drawing, general arrangement. Isometric drawing shall be prepared for prefabrication and thereafter position welding of pipelines and their connections with the equipment is possible. Prefabrication will help to meet completion schedule of piping system and bill of material. And after completion of the project, we have to make as-built drawings. So let us see a piping arrangement. Here you can see in this picture, there is a pressure gauge. Some tanks are installed, tank 1, tank 2. Some walls are shown in the pipeline. Pressure gauges are shown in the pipeline. Expansion joints are shown in the pipelines. Stanchions are shown in the pipelines where supports are provided. So this is a piping arrangement which is shown in a general arrangement. Example for 3D modeling of pipe routing. So this picture will give you a help of pipe routing. So this is a 3D modeling of a pipeline. So this is a 3D model of a feed water line along with pumps and other accessories. So you can understand how the pumps will be installed and how that pipelines will be routed. Material procurement. Once we have finalized all these things, drawings, etc., everything we have decided, and we have calculated the size of the pipes, selected flanges, walls, everything, then we have to do material procurement. A piping engineer or a mechanical engineer will go for material procurement. So after preparation of GA and isometric drawings, material shall be procured as per drawing and technical specifications. Technical specifications are very important and a mechanical engineer must take care of the technical specifications of the material while doing procurement or indenting or making a contract. The engineer shall prepare bill of material, estimate the cost of the material, and tender shall be floated as per technical specifications of the equipment and piping along with pipe fittings, walls, supports, instruments, etc. The material shall be as per ASTM, ASME, NSI, API, MSS standards and tested as per code for acceptance. We know some mechanical engineer has to go for inspection of the material also. So he has to accept the material as per code and as per testing. Only after final acceptance of material they shall be used for process power plant piping. The engineer quality assurance or quality control shall ensure the certificates of testing of material and shall be kept preserved for any future reference because they are very important certificates and they shall be required us later on after the completion of the project during the service of the pipeline. So they shall be preserved. Pipe and pipe fitting. The pipe shall be as per material specification and examined as per tender specification. The thickness tolerance acceptable in pipes is plus minus 12.5% and shall be within limits. The tolerance shall also be seen by weight acceptable limits as per ASTM, ASME, NSI, API codes. Pipe shall be hydrotested or online ECT monitoring shall be done by supplier. During the acceptance of piping and thickness tolerance, this is a very important because the pipe suppliers sometimes cheated us. What they do? Inside of the pipe, they do some painting and they will increase the pipe thickness. So by a general measurement by micrometer, we cannot catch their cheating. So the pipe shall be inspected thoroughly from inside of the pipe, outside of the pipe, and then only it shall be checked for thickness, and then only it shall be accepted. Pipe shall be hydro-tested or online ECT monitoring shall be done by supplier. Equipment shall be as per technical specifications and examined as per code and accepted accordingly. Material shall be stored at site in safe and secure location. Fabrication procedure of piping system. You can see some pictures of fabrication, prefabrication. Fabrication of piping shall be done as per approved procedure and drawing. Without approved procedure and drawing, no fabrication shall be done. A mechanical engineer must ensure that there must be a approved procedure and a approved drawing for fabrication of a pipeline. The WPS welding procedure specification shall be prepared and qualified. The PQR procedure qualification record shall be maintained, and then only the welding shall be carried out on the piping. ASME section 9 shall be referred for WPS, PQR and WPQ. The welder procedure qualification shall be carried out and kept in records. The test piece shall be tested for mechanical strength, and radiography of test joint shall be carried out to qualify welder as per ASME section 9. Before allowing any welder to do welding on the pipeline, he must be qualified, and the test piece which is welded by a welder shall be tested for mechanical strength and a quality of the weld joint. So that shall be done by a mechanical engineer before starting any welding job on the pipeline. Once all above is carried out successfully, then contractor shall be allowed to carry out work. The contractor shall keep all the records of fabrication, testing, radiography, and shall be examined by qualified inspector. The radiography shall be checked at least by ISNT, ASNT level 2 qualified inspector. Erection and supports. After prefabrication of pipelines, we have to erect the pipelines, and proper supports are to be provided in the pipeline. These are very important, and in handling of pipeline during erection, a care must be taken that no accident shall be happen. The pipeline shall be erected as per GA isometric drawing, and connections with equipment shall be made with appropriate gasket and fasteners. So this gasket and fasteners are also very important. We must take care of the gasket. The gasket shall be as per the pressure and temperature, as per the design of the flange. And fasteners shall be also used. Quality fasteners shall be used. A193 grade B7 2HM for carbon steel pipelines shall be used. The joint shall be torqued with torque wrench as per approved procedure. During erection of equipment and piping, safety shall be on first priority, and utmost care shall be taken to avoid any accident. Approved procedures of material handling shall be followed. Supports of pipeline shall be fabricated as per approved drawing and position as per drawing. The support shall be provided as per drawing. By our choice, we cannot provide supports anywhere in the pipeline. Otherwise, your supports will not bear the load of the pipeline, and it can damage the pipeline. The approved electrode shall only use for welding. So the mechanical engineer must take care that the contractor is using approved electrodes by the company or by the department. Without approved electrodes, he shall not be allowed to do any welding. Use of unapproved electrode shall not provide desired strength of weld joint. Support shall be examined and tested, such as dye penetrant test, etc. The wall and mounting shall be erected as per drawings. The contractor shall keep fabrication record of all supports, and test and pipe supports identification marking shall be done as per drawing by paint. As-built isometric drawing shall be prepared after completion of piping fabrication, erection work with detailed dimension and nomenclature. So we must take care while we are carrying out erection of the piping and providing supports. So a mechanical engineer must be very vigilant with the contractors, because contractors can cheat you. They can in hurry, they can do any kind of job, inferior quality of work. So it is a duty of a mechanical engineer that he should keep a eye on the fabrication work which is going on, and erection and supports which are provided by the contractor, which are not, that all should be in line with the drawings. Stress analysis is a very important aspect of a pipeline. Before going for a project of a pipeline, we must thoroughly study stress analysis of the pipeline, and as per that, supports shall be provided in the pipeline and loops shall be provided in the pipeline. The stress analysis of piping system shall be carried out to ensure flexibility in the piping. This is a pre-activity prior to fabrication. The primary and secondary stresses shall be loaded on piping system, and supports and loops shall be designed to take stresses due to pipe fittings, weight, pipeline pressure and thermal expansion under operation. If we will not do stress analysis of pipeline, then during commissioning of the pipeline, your supports will be damaged. Your pipeline can be damaged because the unwanted stresses will block your pipeline and supports. Due to temperature and fluid, the pipeline get heated and expand, which causes thermal expansion stresses in the pipe. This study is typically required for piping that experience high temperature fluctuations, for long pipe runs such as hot piping to coolers or headers, or cross-country steam pipelines. In cross-country pipelines, the pipelines are in a very long length. It may be in kilometers. So in cross-country pipelines, we cannot always go and survey the complete pipeline. So therefore, if cross-country pipeline, steam pipelines are not provided adequate supports and stress analysis is not carried out, then your supports will be can fail anytime, and even though you will not be aware what has happened in your cross-country pipeline, so that can completely stop process of your plant and your plant can come under shutdown. Therefore, we must be vigilant for our cross country pipeline and steam pipelines, hot pipelines, and a complete stress analysis of all pipelines shall be carried out. Cases where equipment is sensitive to external loads may also require a pipe stress analysis. The study methodology becomes more complicated for piping systems in vibratory services. As discussed, the design must address conflicting requirements between the pipe stress analysis, where flexibility is desired, versus the mechanical vibration analysis, which require stiff supports. Methods are available to manage this conflict and create an optimal piping design. The analysis shall be done as per code ASME 31.3 or 31.1. If proper stress analysis is not carried out and supports are not provided, such as spring anchors, sliding supports, guide supports, anchors, as per analysis, pipe and supports may damage during commissioning of pipeline, lead to damage to the public and property. These piping stress analysis software tools are available in the market. CZ2 by Hexagon, AutoPipe by Bentley, CI Pipe by SST USA, Road 2 by Sigma Germany, PAPS by DST Engineering, PAS, Strat, Prof. So these are the some softwares which are available, and a piping stress engineer must do the stress analysis of the piping, and then it should be provided to a field engineer. Hydrotest of piping system. After erection of pipeline, it shall be hydrotested as per code ASME 31.3, 31.1 at a pressure 1.5 times of design pressure, which is now reduced to 1.3 times of design pressure. as per SME Section 8 Division 1. Temperature correction shall be considered during hydrotest pressure for stresses. You can see a picture of a hydrotest of pipeline. Prior to the hydrotest, the system shall be flushed with dedicated test medium to remove all dirt and foreign matters. The pipeline shall be provided drain and vents and shall be opened while initial filling of test fluid water to flush the debris and air venting. Vent valve of highest point shall be opened and drain of lowest point shall be opened. Safety valve shall be gagged during testing. Your all safety valve shall be gagged during testing. Calibrated pressure gauge shall be installed at highest point and discharge of pump to monitor pressure in pipeline during hydrotest. If there is a cross-country pipeline, inspecting team shall take survey of field to ensure that system is intact before pressurizing the pipeline. Chemical cleaning is also very much important aspect after completion of a pipeline. The pipeline and system shall be chemically cleaned prior to begin charging process flow. Cold degreasing is carried out using degreasing solutions of unused 12 hours duration, that is sodium carbonate Na2CO3 3 gallon per liter, sodium triphosphate P3O15 Na2 2 gallon liter, and trisodium phosphate Na3PO4. Rinsing with clean, potable or preferably demineralized water with pH greater than 7 shall be used for rinsing of the pipeline. Neutralization passivation at ambient temperature shall be carried out, circulating a solution of 1% of citric acid in water, preferably demineralized but at least potable for 2 hours, followed by neutralization. Add ammonia in order to obtain pH 9 to 9.5. Passivation, add NaNO2 sodium nitrite up to 10 gram per liter and circulate for 3 hours, 5 hours in static piping. Final rinsing, thoroughly drain the piping and dry with instrument air. Pipe wall shall have a matte grey appearance. After completion of all this, we shall go for insulation and painting. You can see a steam pipeline which is insulated. The hot pipelines such as steam and condensate shall be painted and insulated as per code requirement. The mineral wool used for hot insulation shall have a specified density not less than 70 kg per meter cube. The insulation shall be cladded with aluminum sheet. Cold pipeline shall be insulated with polyurethane foam puff and then cladded. All the piping supports and other pipelines shall be painted as per approved specification except SS pipelines. The chlorine content in insulation material shall not be more than 35 to 50 ppm or as per technical specification allowed. Commissioning and charging. The commissioning and charging procedure shall be prepared and approved by competent authority. The standard approved procedure shall be followed during commissioning and charging of system. The experienced and trained engineer operator shall perform the work. All the valve, gauges, instrument, logic, support shall be inspected and tested and ensured intact prior to charging the system. After charging through, inspection shall be carried out in field by survey team and report shall be prepared of visual inspection or observations. If any deficiencies are observed during survey, they shall be rectified and only after rectification system shall be recharged. All the records and drawings shall be preserved for future references. Thanks for watching the video. If you like this video, hit like button below, share it with your friends and colleagues, subscribe our channel for getting updates on upcoming videos. Please leave any comments, feedback to improve the videos. Thank you.